Example 2 says the manager of a garden store wants to build a 600 square foot rectangular enclosure on the store's parking lot in order to display some equipment. 3 sides of the enclosure will be built of redwood fencing at a cost of $7 per running foot. The 4th side will be built of cement blocks at a cost of $14 per running foot. Find the dimensions of the least costly such enclosure. So it's often helpful with these types of problems to draw a picture. So we have a rectangular enclosure, and 3 of the sides are going to be using redwood fencing, and then the 4th side will use, what was it? Cement blocks. So the red here is supposed to represent the cement blocks. And I'm going to label these, so I'll call this Y, and I'll call this X, and this X as well. And we are trying to minimize the cost, and so we need a cost function. So what is the cost? It's going to equal the basically cost of the how do I want to write this? The redwood costs $7, and so it's going to be $7 per foot. And basically, we're just taking the perimeter of the black portion of the rectangle. And if we add those up, if we add this length with this length with this length, that is going to be x plus y, which becomes x plus 2y. And then the red portion, that costs $14 per running foot, and that has a length of x. So that is what we have there. But the issue is normally when we want to minimize or maximize something, that's when we take the derivative of that function. However, our function currently contains 2 variables, and that's problematic because we can't take the derivative yet. And so we need to somehow make it so that our function that we're trying to maximize or minimize is only in 1 variable. However, luckily we know that the area of this rectangle is 600 square feet. So the way that we calculate area of a rectangle is multiply the length times the width. So we know that x times y is equal to 600. And we can go ahead and solve for one of the variables there so that we can end up doing a substitution. And so I'm going to go ahead and solve this equation for y. So if we solve for y, we divide both sides by x, and we get y equals 600 over x. Now, I'm going to rewrite the cost function a little bit. So cost is equal to, let's distribute that 7 in. So we get 7x plus 14y plus 14x. And then we have these like terms here, so I'm going to combine those. So we have c equals 21x plus 14y. And then now I can substitute in the y value that we just found here into this y value there. So c of, and now our input variable is x, so I can write c of x is equal to 21x plus 14 times 600 divided by x. Let's go ahead and simplify that a little bit. We get 21x plus, and then 14 times 600 is 8,400. And I'm going to rewrite the x so that it's x to the negative 1 power. And hopefully you understand that I'm doing that because we're about to take the derivative. So let's take the derivative of the cost function, and we'll get 21 minus 8,400 x to the negative 2 power. And let's rewrite that as 8,400 over x squared. And then if I found a common denominator and rewrote it, it would be 21x squared minus 8400 over x squared. Okay, so now we're going to take our derivative function and set that equal to 0. And that is equal to 0 when the numerator is equal to 0. So we have 21x squared minus 8400 is equal to 0. And finally, we get that x is equal to plus or minus 20. Now, x represents a distance or a length, and so in the context of this problem, the negative 20 does not quite make sense. And so we are going to work with x equaling 20. Now, we want to test whether that is going to give us a relative max or relative min. So here's 20, and I need to use some test numbers. So let's use 0 and 25. So C prime of 0 is going to be, oh, I can't use 0 because that would give us undefined in the denominator. Let's use 1. So we have 21 times 1 squared minus 8400 over 1, and that is definitely going to be a negative number. And then C prime of 25, that's equal to 21 times 25 squared minus 8400 over 25 squared, and that is definitely going to be positive. And so we go from decreasing to increasing, so that means that when x equals 20, we have a relative minimum, which is what we want since we are trying to minimize the cost. So 20 is looking good. The only other thing that we need now is we have one of the dimensions of the rectangle, and recall that the square, the area or the square footage of the rectangle was 600, and so we found that x was 20. So we have 20 times y is equal to 600, and then if we divide both sides by 20, we get y equals 30. And these are both in feet. So the dimensions of the rectangle that will minimize cost is 20 feet by 30 feet. And that is our final answer for this example.